All about our triangles, theorems, ASA, AAS, and HL. All right, starting with the first one. If two angles are and the included side, so now we're looking at two angles and the included side is congruent to the two angles and the included side of another triangle, then those triangles are congruent, and we call that angle side angle, ASA. So on our triangles, we've got an angle congruent to this angle, this side congruent to this side, and this angle congruent to this angle. So we've got an angle, side, angle. The side is in between those two sides. So if BC was marked over here, that would not be our included side. Okay. If two angles and a included side of one triangle are congruent to two angles and non-included side of another triangle, then those triangles are congruent. We call this angle side AAS. So what does that mean? So we got an angle congruent to this angle. This side is congruent to this side, and this angle is congruent to this angle. So we've got angle, side. So this time the side's not in between the two angles, it's right outside, but they have to be going in order. Okay, if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So now we're talking about our right triangles and a hypotenuse and a leg. So let's look at this. So we call this hypotenuse leg, very clever, or HL. We can only say that they are congruent by HL if they're a right triangle. So don't see two acute triangles and say HL. Not possible. Okay, we're only looking at our right triangles. How do we know it's a right triangle? Remember, one of the angles will have the little square. It's right here. I'll show you. Here's our right triangles, and we know that they're right triangles because of our little square. For the angle, that means that angle is 90 degrees. If we've got an angle that's 90 degrees in our triangle, we have a right triangle. Okay, so we have two right triangles, and we've got this hypotenuse. Remember that the hypotenuse is the one that is across from the 90-degree angle. So that one right there. So we got a hypotenuse is congruent to hypotenuse, leg is congruent to leg, and we've got our 90 degrees. So we call that HL. If the hypotenuses had not been congruent, but the other side had been congruent, so if it was leg with our right triangle, then that's going to be a different theorem that we talked about previously. Right? It's not going. Okay. So some examples state whether they are congruent by ASA, AAS, or SAS. So let's label these. We got an angle, and it's congruent to that angle. Our side is congruent to that side. Our angle is congruent to that angle. So we call that ASA. Remember, for ASA, that side has to be in between those two angles. We basically, when you write out on your paper what we got, angle, side, angle, basically the way that you're reading it should be a theorem. And if it's not, then we need to double check our work and maybe it's not congruent. So here we have, what do we have? We have two right triangles because we got our little squares and our angles. And what do we got? We got our hypotenuse congruent to our hypotenuse. Our leg is congruent to our leg. So we got H. Last one. What do we got? Angle is congruent to angle. Angle is congruent to angle. Side is congruent to side. What do we got? AAS. All right, we are going to practice these. Let me know when you have questions. Remember, when you're looking at whether they're congruent or not, you're looking for those tick marks or the little arches in the angles.